I'll be giving you a demo of the project that I've been doing for my Computer 81 class. The project is pretty simple. The idea is to provide this application with a long URL. It shortens the URL and saves it into two databases. Whenever you try to fetch the short URL, whenever you try to hit the application with internet with the short URL, it redirects you to the long URL. So how it is done? There are two Go servers, the CP server and LR servers. They have three instances running. The CP server actually shortens the URL, pushes it into a queue, which then pushes it into the main database and the LR server. The LR server act as cache. They have data stored there, and once that is done and there is a redirection request, the LR server increase the counter by one and store it in the trend server. So trend server is nothing but a collection of the NoSQL the code that we had implemented in the last assignment. It is a vector clock based database, so it is always synced, and even if there is a partition, the vector clock actually syncs the data correctly. Let's go ahead and see the demo first, and then we'll try to understand how the whole logic and how this whole infrastructure is built, because that is what we're concentrating. So let's do post request yahoo.com. Let's see what our URLs are already there. Okay, so Docker is there, Gmail is there, Yahoo is there. Let's do YouTube. Okay, and if we fetch it, so we are redirected to the correct server. Now if we can we will try to actually hit see the count there, and then I'll explain you the whole diagram of how this works. Let's create the URL. This is my load balancer, and this is it. I'm just hitting it from the Kong API because they are all in the same network. So let's go ahead and hit that. So you see the count is 1. The first time it was hit, it had count 0, and then it incremented it by 1. So this I'll explain you the logic in details. So first let's go ahead and understand the deployment diagram, so how everything is deployed. So there are let's go bottom up. So there's this is the data part of us. This is our data part, and there are two servers. One NoSQL, two servers, two data servers, the NoSQL server and the MySQL server. There are two NoSQL servers. Third, I'll be bringing up for replication. They are connected to the internal load balancer. They have a record keeping server called Zookeeper server, which I am using for a dynamic discovery. The load balancer has only port 9090 exports, but the NoSQL servers have three ports exposed: ICMP 9090 and 8888. MySQL has only 3306 port exposed. They're all auto scales in private subnet and across different AZs. Same is the case with the RabbitMQ. Three ports exposed. I'm using only one for now and one for UI, which I am not using after putting it on Amazon. This is also in private subnet. There are three nodes of control panel which are working on port 3000, and it is connected to internal load balancer again on port 3000. It has two APIs exposed, one for shortening, which is a post request, and one for getting all the URLs. Then there is one server for redirect, which has only one get request. You hit it with the short URL, and it gives redirects you to the long URL. This has support the 3001 exposed. Then again it has three different nodes running all in different AZs. Again auto scaled and load balance. Maximum instances can be three. This is all in private subnet. The only thing that we have in public subnet is the API Kong API gateway. It has two ports exposed, 8001 and 8000. 8001 is for getting and fetching the admin configurations, and 8000 is for actually hitting the server. This is running in DBless mode, and how this is redirecting it to these two servers, we can have a look. It is doing it based on this. So I've created two services based on the URL. If it is a create, it passes through this the remaining of URL to the server, and if we get a redirect, it passes it to the other server, and it is a pass through. So whatever is done written after this part is actually passed to the new server, to the correct load balancing server. So this is the deployment diagram. Now let's go through the uh, how the Amazon instance or infrastructure is built. So let's go bottom up. Zookeeper, it has only one security group, that is for Zookeeper. I'll be showing you all the security groups. Trend server has its own security group. It is again in private subnet. There are two instances running in two different subnets. Zookeeper is also in private subnet, and it is in my own VPC Compete 281. Same goes for redirect servers in three different subnets, again private VPC. It has its own security group. I'll be showing you all this in detail. Same for RabbitMQ, private instance, and private subnet. Kong API is the only one which is public. It is in public subnet, but in my same VPC control panel goes same private subnet, my VPC, and it has its own security group. Oh, we can see the security rules here itself. Uh, so it has only 3000 port open and 2024 SSH, and ADI was trying to hit it initially with the load balancer 8080 port, but then I changed it because it was too much confusing during the demo. And Kong API gateway has port 8001 and 8000 open. The RabbitMQ is this redirect server has only port 3001 open. And let's go to trend server. Trend server has 8888 open, and yeah, yes, so this is 8888 open. And okay, I think these are inbound rules. Let's go to this server. Yeah, I think there was some mess up because of the height of this. So ICMP is open, 89090 is open, 8888 is open, and 80 is open. I am opening this because I need to access it, see if the ping is working, but it can only be accessed from within my VPC. So I have that restriction. Nobody can flood it with my uh, request. Although this is in private number, still I just want it from my own VPC. So this is the infrastructure point of view. We can see the other components like the this is the load the launch config. I've created a launch config for this. Let me show you the auto scaling group first. So auto scaling group is created with a maximum capacity of three servers are running for redirect, control panel, and trend server. There are two. It can be increased to an infinite number, but for the purpose of demo I have done it to 7. This can be auto scaled. uh, this is this is running in all the three availability zones. We can see same goes for control panel, same goes for redirect server. They are directly linked to a target group. Now let's go to the load balancers. There are uh, three load balancers running, one for each, and these are all internal in nature, and they are in private subnets. They have a target group attached, so you can see each target group has healthy, and we can see the port numbers. So this is pinging port number 3000, and let's see the configuration for redirect server. If we go to the load balancer part and we see the load balancer, it is passing through from 3001 to 3000 on the target group. So this is the config. I think we are good here. Let's go to the code implementation, how this was all implemented. So we'll review both the codes, the Go as well as the NoSQL. So this is my folder structure. In the backend there are two parts, Go backend and NoSQL. In the Go there are two servers that have been created, one for control panel. The control panel has two APIs. One is for shortening the URL and one is for getting. The idea is it checks if the URL is already there. If it is already there, it gives you the existing code. If the URL is not there, it creates one URL based on a time based logic. It creates one, Yet this is where it is creating. It pushes it into the MySQL database, and it also sends it to the queue so that it can be saved in the link redirect server. I am using a queue, so this is where it is pushing, and I'm continuously receiving data from redirect server using queue. So this is all done using queues and exchange. Similarly in the redirect server, when there are two APIs that are exposed, the short and the ping. So whenever there is a short URL provided, it sees if it is present in the current system's map. If it is present, it increments the count and sends it to the queue, as well as it increments the count in the load balance cluster of NoSQL. If it is not there, it tries to fetch from the NoSQL database, and even if it is not there, then it gives you a message saying that this record does not exist, please create one. So this is the NoSQL part of it. Let's go to the uh, code. So what we'll do is, what I'll do is I'll increase the count of NoSQL server so that by the time we reach the demo point, we can actually bring up one server. So let me do that because I have to show that for the extra credit. So let me increase the count, desired capacity from 3 to capacity 3, desired capacity 3. So by the time I show you the whole code, it will be up and running. Let's see, let's get this out if I need. Okay, so this is what I had to change in the NoSQL code. So what I did was, instead of having hard coded 5 queue system, I have changed it to a map of queues. So every time there is a new server added, I'll create a new queue for it, add it. Now how I have done it is using Zookeeper. So this is first I'll explain the changes I had to make without Zookeeper. So there were queues, hard coded queues, but now they are dynamic queues, and a map is there to maintain the record of the IP address and the queue. So queue. So there is a relationship, and to get the IP address, what I had to do was I had to hit the EC2 instance, because you cannot get the IP address from inside the Docker container to outside. So when I'm starting it, I do that. Mm, so these I can I'm dynamically adding this to dynamically adding all the entries to the queue, instead of first hard, like the initial phase we were hard coding, but now I am dynamically doing that. Let's understand what happens when you start up a server now. So in the initial code, we had this, the admin app server startup and the admin server startup, but I'm adding one more thing called on startup application startup node. So what I do here is I have a Zookeeper server that is running. It maintains, it creates the parent nodes. If there are no parent node, there are two parents node that I create, all nodes and the live nodes. What all node does is it maintains the list of all the nodes that are there. So even if one node goes down, it maintains the record. Okay, this was node 1, this is these are nodes, and I save it in form of node number and the the map number. I can show you ls star. So you see, this is the first node, this is the first node, and this is the second node. This is the IP address. We can validate that. Similarly, if I do ls live live nodes, so these are the live nodes. So if there are more live nodes, this will keep on increasing, but here we will have two nodes only. So I think the server is still coming up. So let's, okay, let me explain this first, or I can actually bring that server. Now what happens after that is it gets the count of the current server, increases it by 1, and saves it to the all node part. It does the same thing with live nodes and all nodes, so the record is saved there. Once I have this live node, I need the copy of data which is already existing. So first thing I do is I replicate. First I replicate, and then I register first, or rather first I register the node, and then because this node has to be registered in the server, that okay, this is the node, this is where the current server will actually maintain. So I fetch the record of all the existing nodes, run a map through it, register each and every node so that whenever a queue has to be sent, the dynamic queue I was telling, so each node is sent a sync request. So whenever there is update, a sync request is sent. I register port 8888 and 9090 because we are on different EC2 instances. It can be directly maintained. I am taking the first part only because the second part is the map number, which I don't need. I start the thread like we were previously doing. So this is where I run the queue and add to queue. This is what I was talking about, current node and node sync queue. Now, this is the part where I'm actually getting all the data or replication. What I do is I'll check that I need data from any other queue except itself. So this is I get a random IP based on the record. So what I do is I fetch the IP of another node, which is it should not be itself. I get that IP and I continuously check if it is the same IP. It is same as mine IP, don't get it. Once I have it, I replicate the queue. For replication, what I do is I've created this. So what I do is uh, I I make a replication request. The replication request, what it does is the map of existing data, key and value pair. I fetch that record, and I fetch that record, and once that is fetched, I save it into my own database. So let me show you quickly. Okay, see, this is where it is happening. I fetch it and I replicate the document. So what I'm doing is I'm creating a new record, saving all the values and pushing it to my key map cache and document history. That was my logic of implementation. So I have the updated ones. What if that record is already there? If that record is already there, it means there was a change in the vector clock. So what I do is I don't replicate the document. I just replicate the vector clock, and I just copy the vector clock and I push it. So this is how the replication works. Both the cases are handled. Now let's quickly bring up the servers. I'll hold on for a second. So there should be a new instance that might have come. Okay, let's see. Let's see if this is the new server. Uh, let's exit it. Dot slash send. Okay, let me I have stopped the server manually. Now let's see if sudo su I'll explain you how this is implemented. Docker ps. Okay, so this is I have stopped it. So I the server was stopped. Now let's first docker ps minus a. Let's try and delete the old one, because we will bring it up manually to see how the replication works. This is what I wanted to show you. I have a command that I had written, the shell script that I was talking about. I want to show you how we are actually fetching all that information lively. This is all done in the systemctl way, but for the demo I stopped it, and I have let me show you. So this is the docker command to start the server. This is my IP address of my Zookeeper, and this is to get my current IP. This is the command that I'm using. So to get my current IP, I'm curling on this particular Amazon instance IP that was provided by them. I fetch the metadata and I get my local IP address from here. Again, I am okay. So let's run this command. This is my EC2 instance. We will see it happening live. Okay, so this is deleted. So now we don't have any image present. Let's get out of it. Let's bring this server up. and we'll see the logs. We will see how the replication has happened. Once we have that, we will be able to see all the data is correctly fetched or not. This has already been done by systemctl. I'm just bringing it up so that we have a live demo of how replication happened and how the Docker containers are started, how it fetches the API and everything. Okay, so let's see Docker PS. Okay, so there are two ports exposed, 8888 and 9090. 8888, let's go. 8888 is for the sync request, but we do not need it from external access. We only need it 9090 because that is what the API port is. As I showed you in this request, I am getting 8888. The servers internally communicate using 8888 for node registry and for sync request. So let's go into the Docker container, Docker exec minus IT, no SQL, um, bash. Okay, we are into it. ls cat SQL. Okay, so this is there was there was a lot of data. So if you see, it is first getting this replication count. This is for my testing. There are three nodes that are registered. Previously there were two, now there are three nodes registered. This is the replication data. These are all the key value pairs, and it is replicating all the documents one by one. And now if we go ahead and see the Zookeeper live nodes, there should be three nodes. Yes, there are three nodes, and then there are three nodes in this. Now what will happen if I actually stop one of the servers? Now there should be one decrement in the live nodes, but there should not be a decrement. So what we'll do is, for the purpose of testing, let's bring down one node and see if Zookeeper is able to dynamically handle it or not. So what we'll do is, we'll not bring down the EC2 instance, we'll just bring down the Docker container so that live node stops pinging. That is similar, because if we bring down the whole EC2 container, it'll just spin up another one and we'll not be able to check that. So let me bring this down. DOCK stop. Okay, let's in the meantime see if our load balancer has been updated or not. It should have gone to the healthy state. Otherwise it might be taking some time. We can still check. It will already would have registered, although so it was still not healthy because it takes 300 seconds to come up, and we have already brought down this server. uh, let's see if our server is down. Yes, Docker PS. So our server is down. Let's go to Zookeeper and see. All nodes still has three nodes, but live nodes has only two nodes. So now if we bring another fourth server, what it'll do is it'll add another server to the all nodes with counter number 4, and with the live nodes will have only 3, 1, 2 and 4, not 3, because if it puts it to number 3, then the vector clock sync will go out. Vector clock sync will be messed up because we are basing it on node number. So the previously we had like 1 2 3 4 5, and the API documents API node 1, node 2, node 3. Similarly here we are maintaining the records using the node numbers. So this thing has to be constant, otherwise this thing has to be global, because if this messes up, the whole system messes up. So this was my whole idea. The Zookeeper part was the for extra credits, and this was the interesting part. You can check out. Okay, this implementation of Zookeeper has been inspired from B. Katwal's blog on medium.io. I would like to give him credit for his help, his understanding. There are some methods, you can check the code out if you want. B. Katwal is the name of the writer, and it is on medium.io. I would especially like to credit him because it is inspired from his code. If you have any comments, please feel free to leave the comments in the YouTube video. Thank you.